Okay, today we start including some more formulas, the sum and difference formulas. So feel free to Google why these formulas work. We are just going to learn them and use them. So if you have sine of a plus b, that ends up being equivalent to sine of a times cosine of b plus cosine of a times sine of b. If you had the minus equation, that ends up being basically the same thing, but with minus in the middle. So notice that for sine, if it's plus, the symbol in the middle is plus. If it's minus, the symbol in the middle is minus. The signs match when you expand it. For cosine, so if you have the sum of the cosine of the sum of two angles, and you'll see why we break it down into the sum of two angles when we start examples, it ends up being cosine of the first times cosine of the second minus sine of the first times sine of the second. If you had the minus one, it ends up being basically the same, but with a plus sign in the middle. So for your cosine expansion, if it's plus, it ends up being minus. If it's minus, it ends up being plus. The signs are different. Tangent, you guys can read this. You can either do your answer to sine over your answer to cosine, which is what we'll do most of the time, or you can do tangent of the first plus tangent of the second over 1 minus tangent of each. So for the tangent formula, if it's plus, the top is still plus, it's the same, but the bottom is minus, it's opposite. If it's minus, the top is minus and the bottom is opposite. So the numerator has the same sign and the denominator has the opposite sign. So there is a little song to help you memorize these. So I'm going to write it down with no symbols, right? We've got the answer to sine ends up being sine A cosine B, gap, cosine A sine B. That's a mess. Sine B. The cosines end up being cosine A cosine B, gap. The gap is for the plus or minus sign, right? Sine A sine B. And then tangent ends up being tan A gap tan B over 1 gap tan A tan B. So the song goes like this. Ready? Sine, cosine, cosine, sine, cosine, cosine, sine, sine, tan, tan, 1 tan, tan. And that helps you remember which trig function it is. And then you need to remember sine, same symbol, cosine, opposite symbol, tangent, same on the top, opposite on the bottom. Sine, cosine, cosine, sine, cosine, cosine, sine, sine, tan, tan, 1 tan, tan. Okay, here we go. Well, why the heck is that useful, right? So not every radian is a special radian where you can do it in your head and use special triangles, but many radians can be broken down into special triangles. I also need you to understand that there's more than one way to break these down often, but I'm going to make some decisions for us, especially since I'm home alone making this video, right? So we've got pi over 12. We want to break it into, what are the pi's that we like? We like pi's over 3, pi's over 4, pi's over 6, and some pi's over 2s, right? So those are the ones we have options for. So if I want to get pi over 12 either with addition or subtraction, one way would be to do like 4 pi over 12 minus 3 pi over 12. That definitely equals 1 pi over 12, right? And then the reason why I chose those is 4 pi over 12 reduces to pi over 3, and 3 pi over 12 reduces to pi over 4. Those are on the unit circle. So I am going to replace the pi over 12 with this. This equation would give me pi over 12 as well. So the equation now is going to say cosine of, keep them in the right order so that you get the answer you want, right? This. So basically, this is A, and this is B. It's a minus problem, right? So Sine, cosine, cosine, sine, cosine, cosine, sine, sine, right? So cosine the first one, cosine the second one. I'm going to leave a gap. Sine the first one, sine the second one. And then cosine, is the sign the same or opposite? For cosine, if it was minus, this is going to be opposite plus. For cosine, the sign is the opposite. Now, why did we do this? Well, now every single one of these is a unit circle problem. I guess I'll draw a circle over here, but you guys should really be able to do some of these in your head without drawing it is the goal, right? All of ours are pi over 3 and pi over 4. I'll label those so that you know where to look each time. So, cosine is the x. What's the x at pi over 3? Well, it's 1/2. Cosine is the x. What's the x at pi over 4? Well, it's root 2 over 2. So this was the answer to the yellow piece. This was the answer to the pink piece. Problem says plus because it's opposite. Sine at pi over 3, the y value. Sine at pi over 4, the y value. Then we do a little multiplying, right? Straight across. Multiply the tops, multiply the bottoms. Multiply the tops, multiply the tops, multiply the bottoms. Notice the denominator came out to be the same. That should happen every time. And you get root 2 plus root 6 all over 4. And if you took the time to type in, you'd have to use radians, cosine pi over 12. It would give you some crazy decimal. And then you typed in this green box, it would give you the same crazy decimal. But we were able to do it with special triangles and we didn't need a calculator at all. Also, does it matter what order you add things in? No. So it could also look like this. Same thing. Obviously, subtraction does matter the order you add it in. And also, you cannot actually add root 6 plus root 2 by hand. This is what your answer looks like. Let's try another one. So again, lots of choices, but I'm over here making some decisions how we get it. I need to get negative 5 pi over 12. Well, one way could be, you want to think of things that reduce, right? So I don't want to use like 1 pi over 12 and minus 4 pi over 12 because 1 pi over 12 doesn't reduce. So think of the numbers that reduce into 12, right? 2, 3, 4, 6, 8. A lot of numbers reduce into 12. So what if I do 3 twelfths minus 5 twelfths? How about 8 twelfths? I was going straight to the answer, wasn't I? 8 twelfths. Make sure that that gives you negative 5 twelfths. It does. Now reduce them. 3 twelfths is pi over 4. 8 twelfths reduces the 2 pi over 3. So that's what I'm going to replace this with. Notice it's a sine one, right? Sine, cosine, cosine, sine. So hold on. First, I should write the question. So sine of, I'm replacing it with pi over 4 minus 2 pi over 3. Because my work in red just showed me that that's the same. Now I'm at sine, cosine, cosine, sine. So sine of the first, cosine of the first, gap, cosine of the first, sine of the first. Both pieces will never be identical, right? If they came out identical, you did something wrong. So then sine, it says minus. Is sine the same or opposite? Sine is the same, so minus. Now do your unit circle, maybe draw one. Everything in this problem is at pi over 4, which is here, and 2 pi over 3, which is here. Pause the video and see if you can find the 4 answers. Do each part separately using your unit circle. So at pi over 4, the sine value is root 2 over 2. At 2 pi over 3, the cosine value is negative 1/2. Problem says minus. At pi over 4, the cosine, the x, is root 2 over 2. At 2 pi over 3, the sine, the y, is root 3 over 2. Multiply straight across. Negative root 2 over 4. Problem says minus root 6 over 4. Notice the common denominator, negative root 2 minus root 6 all over 4. If I used a calculator and did this in radians, it would equal whatever that gave me as a decimal as well. Again, as long as you keep the symbol in front the same, it is also equivalent to that. Okay, why don't you try this one on your own, actually? And all I'm going to do is give you the final solution. I am not going to work out number 3. I could give you one suggestion maybe on how to do the 13 pi over 12. I don't know, why don't you try 3/12 plus 10/12, right? That reduces. And then see if you can do the entire thing, and I will show you the answer. Okay, I showed you a tiny bit more than the answer, but if you finish this one, you should get negative root 6 minus root 2 all over 4. Okay, moving on to tangent. So remember, free response test, I'll tell you what this usually looks like in the free response test, right? We're going to ask you for sine of 7 pi over 12, and you're going to get an answer. We're going to ask you for cosine of 7 pi over 12, and you're going to get an answer. Then when we ask you for tangent of 7 pi over 12, that could be, one of the ways you can do it is take your answer to sine and divide it by your answer to cosine. That might be quicker sometimes. But multiple choice, we're not going to give you a problem within a problem. So you can just jump right into the tangent formula as well. That's another option. So we're going to need to break this up into ones we can use. 7 over 12. 3 plus 4. 3/12 plus 4/12. You have options in the future. You don't have to use mine. That's pi over 4 plus pi over 3. So this is the same as tangent of pi over 4 plus pi over 3. Okay, tan, 1 tan, right? So tan of the first, tan of the second, 1 gap, tan of both. Tangent, same on top, opposite on the bottom. So we have pi's over 4s and pi's over 3s. I don't know that drawing tangent is helpful at pi over 4 and at pi over 3. Knowing what quadrant it is helpful though. So tangent at pi over 4 is 1. Tangent at pi over 3, it's positive because it's uphill. And then pi over 3 has 1 3 in it. So that's just root 3. I'm not going to draw these parentheses around my 1. So again, 1 plus, that comes out to be root 3 over 1 minus, and it's those same answers again. 1 times root 3. So I get 1 plus root 3 over 1 minus root 3. If you typed this in and got your crazy decimal, it would be the same thing if you typed that in radians. So this is what our solution looks like. I'm afraid I should teach you how to rationalize this just in case. If this is not what the answer looks like in your multiple choice, that's because they're not allowed to have a square root in the denominator. To fix that, you multiply by the conjugate, which is 1 plus root 3. When you do that, you do an area diagram. On the top, if you multiply, you could do FOIL, right? 1 times 1, 1 times root 3, 1 times root 3. When you add those together, you get 2 root 3. And then root 3 times root 3 is just regular 3. On the bottom, that's a difference of squares. You're going to get 1 minus 3. You can feel free to do this in in an area diagram to check. Sorry, it glitched. Hopefully you're with me. The top's going to be 4 plus 2 root 3, and the bottom's going to be negative 2. It might even reduce that. Both of them divided by negative 2. Negative 2 minus root 3 could be what the answer looks like instead. If it's the multiple choice test, you are allowed a calculator. So it might just be easier to take this decimal and check and see if it matches that one. Or check and see if it matches answer B. Or check to see if it matches answer C, etc. Because in class, free response final, we are going to stop here. Just a heads up. Okay, so now we're going to put our sum and difference together with the draw the triangles problem that we've been doing, right? So each piece is going to represent a different triangle. So you've got triangle U, and here's the information to tell us what triangle U looks like. Plus, and then you've got triangle V, and here's the information to tell us what triangle V looks like. So we're going to do one at a time. So for triangle U, the yellows. If I look at this, it tells me which quadrant it's in. So it's in quadrant 1, between 0 and pi over 2. Then if I look at this piece, it tells me sine has to be 4 over 5. Theta's here. Sine has to be 4 over 5. Pythagorean Theorem, right? We've done these before. Do Pythagorean Theorem. This side ends up being 3. Remember to check for any negatives. So this is the triangle we're going to use when it says U. Now the pink one. Looking at the pink information. If I look at this piece, it tells me which quadrant it's in. Between pi over 2 and pi is quadrant 2. Theta's here. If I look at this piece, it tells me what cosine is going to equal. Cosine, adjacent over hypotenuse. Hypotenuse can never be negative, so this must be negative. Pythagorean Theorem, I am no longer showing my Pythagorean Theorem work. X squared plus 12 squared equals 13 squared. This side ends up being 5. This will be the picture I use anytime it talks about V. So I am color coding. You also might want to just label them. This is U and this is V. So the problem says sine of U plus V. So you're going to expand it. Use your song. Use your sine, cosine, cosine, sine, right? So that's a sine problem. So that's going to be sine, cosine, cosine, sine. The symbol for sine matches the problem. So this is V's and this is U's. Then when you go to find out what sine U is, you have to look at the triangle. If I'm looking at triangle U, sine is 4 over 5. When I go to find out what cosine of V is, I need to look at the correct triangle. Cosine is negative 12 over 13. Problem says plus. Now it wants cosine of the U triangle, the yellow one. Cosine of that is 3 over 5. And now it wants sine of V, the pink one. Sine is 5 over 13. Multiply tops, multiply bottoms. Multiply tops, multiply bottoms. Notice the common denominator. If that doesn't happen, you did something wrong. Common denominator for negative 48 plus 15 is negative 33 over 65. This would be the answer. So use all the given information to draw the triangles, and then use your triangles to answer the little pieces along the way. So let's try another one. So we've got U's and V's again. Use this information to draw triangle U. Use this information to draw triangle V. See if you can get those triangles fully drawn. Draw them, label them, and find the missing sides. We did this in chapter 4A. For the yellow one, it tells me it's in quadrant 4. I'm sorry, between pi over 2 and pi, quadrant 2, here. For the pink one, it tells me it's between pi and 3 pi over 2. That's quadrant 3, here. Back on the yellow one, sine of theta equals 1/2, opposite over hypotenuse. Pythagorean theorem to find the missing side, and then look at your picture. Pythagorean theorem is going to give you root 3, but my picture gives me negative root 3. Remember how many of you got that wrong on the 4A free response? You want to make sure you keep an eye out for those negatives. This is triangle U. See if you can finish the pink one. Triangle V. It says cosine is negative root 3 over 2. Cosine, adjacent hypotenuse, but hypotenuse can never be negative, so the adjacent is. Pythagorean theorem gives me an answer of 1, but my picture tells me it's -1. This is triangle V. The problem wants us to do cosine of u minus v. Expand it with u's and v's first. Sine, cosine, cosine, sine, cosine, cosine, sine, sine. Cosine, cosine, sine, sine. Cosine symbol is always opposite when you expand it. Now look at the correct triangles and answer the little pieces. Cosine of the u picture, adjacent over hypotenuse. Cosine of the v picture, adjacent over hypotenuse. Plus sine of the u picture, opposite over hypotenuse. Sine of the v picture, opposite over hypotenuse. Multiply tops. Negative times negative goes away, and √3 times √3 is regular 3. 2 times 2 is 4. Multiply tops. Multiply bottoms. 3/4 minus 1/4 is 2/4, which is 1/2. The answer to this question is 1/2. Okay, one more. Again, see if you can draw the yellow triangle, draw the pink one, and label all the sides correctly. Actually, we should look at this. Let's expand it. I want to finish highlighting it. You're welcome to draw the triangles, but tan u plus v, tan's special, right? So tan, 1, tan, tan, 1, tan. Top is the same, bottom is opposite. Well, looky here. Tan of u and tan of v. They are given every single time. So let's just plug them in. Tan of u is given as 1. Problem says plus. Tan of v is given as -√3/3. Over 1 minus, and the same things. 1 -√3/3. So I am at 1 plus, how about 1 minus √3/3 over 1. Negative times a negative, so plus √3/3. Fractions and fractions are never allowed. I've taught you how to deal with this multiple times. Multiply everybody by the common denominator, because that will cross some things out. 3 times 1. 3 crosses out with 3. I'm just left with minus √3. Over 3 times 1. 3 crosses out with 3. I'm left with 3 plus √3. If this is not the answer you see in the multiple choice, make it a decimal. Make everybody, all the choices a decimal, and choose the correct one. Okay, using x's instead of numbers. It's going to be the same idea. So eventually we're going to take cosine of, this is all just to give me the picture of the yellow triangle. And then we're going to do this one to give me the picture of the pink triangle. So we are going to do, remember when it's a variable, it's always in quadrant 1. So here's triangle A is what I'm going to call it. This is the same as cosine of A minus B. Eventually we'll get to this point. 90. And then triangle B. The second triangle, the first triangle. Okay, label it based on what it says. So for arctan to be 5x over 7, tangent, opposite over adjacent, must look like this. Pythagorean Theorem, to fill in the missing side, remember you're going to do 7 squared plus 5x squared, and it's going to equal c squared. This is 49 plus 25x squared. So this is going to be the square root of, and addition does not matter the order, so I prefer my x's in front. You cannot square root both terms. That kills the puppies. Remember, you cannot square root across a plus or a minus sign. So the hypotenuse of that triangle looks just like what I wrote there. And then the pink one, sine has to be opposite over hypotenuse. So label it the way it's given. When you do that one, 8 squared plus b squared has to equal x plus 2 squared. So b squared is going to equal, don't actually multiply this out because it's a mess and oftentimes people do it wrong. and you would minus the 64 to that side, and then you end up taking the square root, and this side is going to be the square root of x plus 2 squared minus 64 squared. Which one is negative is super important on that one. So now I'm here. I'm at cosine of A minus B. Well, sine, cosine, cosine, sine, cosine, cosine, sine, sine. Cosine, cosine, sine, sine. Cosine is opposite. The problem was minus. This is going to be plus. But now I look at the correct triangle to answer the question. What is cosine of the first one? Cosine, remember theta's in the bottom left corner, sorry. Cosine of that one is 7 over square root of 25x squared plus 49. Cosine of the second triangle is square root x plus 2 squared minus 64 over, I'm just doing adjacent over hypotenuse, x plus 2. Problem says plus. Sine of the first triangle, 5x over square root of 25x squared plus 49. Sine of the second triangle, 8 over x plus 2. Okay, multiply the tops, multiply the bottoms. When it's just a number times a square root, you can write that in front of the square root. When it's a binomial times a square root, that can also go in front, but it needs to be in parentheses. If you don't have parentheses around your binomial, when you're multiplying, it will be marked wrong. Problem says plus. Multiply the tops. Those can actually multiply, right? 8 times 5 is 40x. Notice the denominators match. Again, if your denominators aren't matching in these problems, you're doing something wrong. So common denominator, it's just going to look like this. 7 root x plus 2 squared minus 64. Make sure your root doesn't go too long. And then plus 40x on the outside, all over a single common denominator of this. This is our final solution. That would be the messiest thing I would expect to see if I was you, is these problems. Okay, see if you can do it now. Use this information to draw the first triangle. Fill in all 3 sides. And then use the second piece of information to draw the second triangle. And we're going to do sine of A minus B because it says minus. This will be triangle A. Over here is going to be triangle B. Secant. Secant is cosine reciprocal. So instead of adjacent over hypotenuse, they gave me hypotenuse over adjacent. Pythagorean theorem carefully ends up being square root of hypotenuse squared minus leg squared. Tangent, opposite over adjacent. Pythagorean theorem carefully ends up being square root of leg squared plus leg squared. So expand. Sine, cosine, cosine, sine. Sine is the same symbol. Now find each of these things. Remember, triangle A, triangle B. Sine of triangle A, opposite over hypotenuse. That's not going to reduce. These are never going to reduce. That is the answer to sine of the first one. Cosine, adjacent over hypotenuse. Problem says minus. Cosine of A, adjacent over hypotenuse. Sine of the second one, opposite over hypotenuse. Common denominator, parentheses because it's a binomial, and then multiply the tops correctly. Binomial times the square root, binomial in parentheses in front of the square root. Problem says minus 9 times 5, 45. This is our solution. Nothing ever reduces. Every parenthesis you see is necessary. Okay, if there is another problem on your notes, we will do that together in class. So this is good for today. Hope you guys are doing good.